In this tutorial, you will learn how to control a single servo with an Arduino device. The materials that you will need are as follows: an Arduino board, jumper wires, a USB cable, and at least one servo. Now it's time to begin construction. Our first step will be to supply power to the servo. I will connect the red jumper wire to the 5-volt output on the Arduino. And now I will connect the black jumper wire to the ground. The orange jumper wire will be connected to digital output pin number 10. The orange wire will be used to send information to the servo, and the black and red wires will be used to power the servo. Now you should connect the jumper wires from the Arduino to their corresponding colors on the servo. When finished, you should have a wire going from ground to the black wire on the servo, 5 volts to the red wire on the servo, and one of the digital pins to the orange wire on the servo. Now it is time to begin programming our Arduino. To program the Arduino, we must first download the Arduino Interactive Development Environment. Using the power of Google, we can navigate to the Arduino download page and download the Interactive Development Environment. Once on the Arduino website, you must select the download appropriate to your operating system. Once the Arduino development environment has been downloaded, you may then open the application and begin programming. The first step in our servo example will be including the servo.h header file. This file includes many functions which will simplify controlling a servo with an Arduino. We must now instantiate a servo object to represent our physical device. The first method we must implement is setup. This method is of the type void and will take no parameters. Within the setup method, we must declare to which pin we attached our servo during construction. For me, this pin is 10, but the number may vary depending on which pin you connected to. The next method we must implement is loop. This method is of the type void and takes no parameters. To set the angle of our servo, we must call the right method and pass it the angle as a parameter. The delay function specifies the amount of time for which the Arduino is to wait before performing the next operation. The delay function is passed an integer representing the number of milliseconds for which it is to wait. We now repeat the instructions by increasing the original angle of 45 by 45 degrees each time. The intended result is a servo which will set itself to 45 degrees, wait for 1 second, set itself to 90 degrees, wait for 1 second, set itself to 135 degrees, wait for 1 second, set itself to 180 degrees, wait for 1 second, set itself to 0 degrees, wait for 1 second, and then repeat. Rather than implementing this labor-intensive method, a for loop ranging from I equals 0 to I equals 4 could produce the same result. I would serve as a multiplier and 45 degrees as a base. The right method would then be passed I times 45 degrees as a parameter. After connecting the Arduino board via USB, you must click the Upload button to program the Arduino. Once programmed, this should be the result. As you can see, the servo does exactly as we programmed it to do. Thank you for watching, and any comments or suggestions are appreciated. In the next video, I will show you how to control 2 servos with a single Arduino board.